Hello and welcome to NOV Live. I'm Michael Gaines and glad you're joining us today as we continue our ongoing conversation, bringing you technical experts and conversation from innovators and leaders from around the world, and bring all that to you here on LinkedIn, YouTube, and Facebook Live. So glad you're joining us today as we continue that conversation. And our conversation today is certainly a good one. We're actually going to be diving deep, talking about subsea storage units and a joint industry project there. So definitely will be something that you'll want to tune in for and be a part of. So as we kick off our show, we're going to go ahead and bring in Shelby Dumaine to kick us off and tell us how you can not only be a part of the conversation, but as always, give us our anticipated trivia of the week. Hey, Shelby.
Hey, Michael. Yes, if you're watching this at home and you'd like to get involved with today's show, you can do so by commenting, whether you're on Facebook, LinkedIn, or YouTube. You can put any questions you have for our special guest in the comment section. I'm there throughout the entire show, watching everybody comment, seeing what everybody's saying. I usually like to check those questions and kind of see maybe where everyone's tuning in from. So right now, I'm seeing Saudi. I see, I think, Houston here, Oklahoma. So thank you, everybody, for joining so far. Go ahead and let us know where you're watching from. And then, like I said, if you have a question at any point during the show, you can comment those there in the comment box, and we're going to get to as many as we can after Michael and our guest have their conversation. And I wanted to mention, too, if later on, if you have a question about maybe a past episode or an idea for a future show that you would like to see us talk about, you can get those questions to us by emailing us at socialmedia@nov.com. So we have that email on screen there. And I know I mentioned past episodes. So if you wanted to watch any of our past episodes, the best way to find them is to go to nov.com/live. So like I said, if you want to watch past ones there, that's where to do it. And then if you have questions, please feel free to email us, and we'd love to get your question answered. And so that's all the different ways that you can ask us your questions. But now it's one of my favorite times of the show. It's where I ask you a question. It's time for Rig Geek Post of the Week.
Rig Geeks Post of the Week.
All right. You know, I always like to keep our rig geeks on their toes with these questions. And I think we have a very scientific question. So I always say, get your math hat on, get your science hat on. Our question today is, what is the depth range for storing ammonia in a membrane subsea? So if you think again, I'll repeat that question again. And it is on screen too, if you'd like to read it. What is the depth range for storing ammonia in a membrane subsea? And that might be a little bit of a hint of what we're talking about. But I'm interested to see what our rig geeks, what our rig geeks can guess in the comments.
So, I mean, I don't mean to disrupt our flow here, but I just want to confirm. So, will you take that answer in both inches, centimeters, meter, any unit that I'd like to provide that in?
I think we have it in miles, maybe, but
okay. Well, you might have to do some conversion on the fly then. So
yeah,
that's okay.
If you do it in inches or centimeters, I might have to guesstimate.
No, that's fine. All right, cool. All right, looking forward to it. Thanks, Shelby. All right. Well, as Shelby mentioned and alluded to, of course, we talked about at the top of the show. Today, we are talking about subsea storage. And it's really a fascinating topic. And of course, the technology around there is absolutely leading here. And so what we want to do is have the opportunity to bring in today's technical expert. We have the opportunity to talk to Marius Bjorn. He's the business director for Subsea Products. So Marius, thank you for joining us. And for those that haven't been able to get out and about, where are you joining us from today?
I'm joining you from Oslo, Norway. So yeah, we have 50 centimeters with snow outside, so different than in Houston. Yeah,
I would have appreciated a little bit of landscape and you taking the call outside, but I know it might have not been the best. So so thanks for joining us. All right. Well, Marius, I know that we've talked a little bit about subsea storage in the past, and really think that it's like I said, a really fascinating topic. I know it's something that you're passionate about as well. So for those that either may not be familiar or as up to date on subsea storage, especially here at NOV, can you talk a little bit about some of the motivation and what kind of the thrust was to get into to the subsea storage space?
Well, thank you, Michael. Our motivation is to develop unique technologies that can bring our industry one step forward. Of course, the requirement today is also that it shall reduce the environmental footprint. So the way we see it is that NOV, they are mainly, or we, at least Subsea, we are mainly a product supplier. So we want to work with both the integrators and the operators. I will now show a video that explains how we are thinking. So please start the video. As you can see here, the subsea storage that can be used together with the flexibles and both risers and flow lines. You can see we have water treatment systems for water injection. There we can use subsea storage. We have our APL offloading solutions. They are very important together with subsea storage. The composite, we have fiberglass system. That's our composite manufacturer. And with the goal together with them, we can lower the structural weight. We have mobile units and conductor connectors. Here again, we have the subsea storage for tiebacks. That's very important. That can be an enabler for that technology. And together with topside process equipment, it can also be used as to lower the topside weight. So here on the wheel, we can see that the subsea storage has a key role in several of our technologies and systems. So thanks.
Okay, no, that's really good, and I appreciate that graphic. It kind of was really well lays out how everything is integrated there. So excuse me. So when we last talked about subsea storage, we got a good overview of some of the technology there. But again, just want to kind of dive in there, pun intended, I guess, in this case. Could you talk a little bit about some of the background, but specifically with subsea storage, why we find it to be a need for the offshore production space?
Yeah, I think I will divide that question up in three. We have several systems for subsea storage. The first one is the oil storage. Initially, the idea was to use the seabed to store oil and condensate in our storage tanks, because there are many fields with a lack of infrastructure. So then to have a storage solution like this would simplify many of the field developments. It has always, earlier it was common to use FSOs, floating storage units, and that's more like ships where you can store the oil. But of course, those ships, they are using diesel or running on diesel, and they are not that friendly towards the environment. So that was one of the key enablers for this. Of course, technical solutions are important as well. Earlier, it has also been, there are about 8 to 10 fields in the world today where you actually have subsea storage, but those systems are made of concrete and steel. They are quite huge, and they do not have the membrane inside the storage system as we have. So that then the system will be oversized, and that's a very big difference between that system and our system. Then after oil, we can also store chemicals at the seabed, and that's smaller tanks, And chemicals are needed to improve reservoir conditions, to improve the flow assurance in flow lines, for hydraulic control, and during startup and shutdown of wells. Our industry has for years developed the all-electric control with the goal to remove the hydraulic tubing on the valves and actuators. So that means that if we shall reduce, or if we shall remove the umbilical, we also need to remove the chemicals, and that's where our storage solutions can be an enabler, because then you will have the chemicals located close to the wells. The last one, and that's something that has actually been developed just the last 6 or 12 months, is subsea storage of ammonia. Ammonia is very exciting, and for sure it's one of the big drivers for renewable energy. First, I will say that ammonia, that's a hydrogen carrier. So when we are talking about hydrogen, we are also talking about ammonia. So for ammonia, it is very important to have low pressure and to have high pressure and low temperature. Then you can store ammonia in a liquid form. So below 100 meters, you can actually store ammonia in liquid form, and it will not be a gas. So what have we done so far? I have a picture with our development, and here you can see where this started. Actually, we have done several phases, and we started in 2012 with to buy a patent and develop that. As you can see, that to develop something for subsea, that takes years. Someone tells us that it takes 5 to 10 years to develop a new technology, and we are there. So then we have done different phases, and in 2013 we did a qualification study together with Equinor and other partners. We tested membranes and protection structures and how to install it on the seabed. Then we have done several feasibility studies for many operators. But the big change was 2 years ago. We started with a parameter test. I will show you more about that afterwards. But there we made 3 prototypes in small scale prototypes that we tested together, and cyclic testing with those, and we learned a lot. So now we are entering into phase 4. That's the big and last phase. We are calling it large scale testing. So that's perhaps the most important one just now.
So in addition to you're talking about testing and of course your large scale testing, which then kind of leads me into the question regarding qualification. So I recognize that there are always a high degree of testing and validation, and certainly curious to know what that looked like from a qualification standpoint here for the subsea storage space.
Yeah. Thank you. I will then go back to the qualification that we did together with Equinor and OGTC for the small scale testing, and here you can see a movie from that testing. We learned, as I said, a lot. To do cyclic testing, to testing overpressure system, to testing refilling, to testing the membrane behavior, and things like that. That's very important. So what I will like to say is that we have now moved forward from that phase, and that's when we also learned that we need to go to a bigger scale. because in this project we used 3 cubic meter tanks, and the biggest tanks that we are developing for subsea use, the intention is that they shall be up to 10,000 cubic meters, or about 60,000 barrels, and that's just one tank. And then you can put them together in a cluster with several tanks,
Mm-hmm.
so it can be bigger. Yeah.
Oh, sorry. Please. Yeah. So no, I would. The junior engineer inside of me is really wanting to jump out here, because I see the subsea storage units, and I just really want to know, really how does it work? Because it looks really, really innovative, very kind of cutting edge. So, I mean, to the degree to which you can share, can you explain a little bit more how do these units work?
Yeah, I think I then also will start with a short video again.
Okay.
And here you can see how we are filling and emptying the storage unit, and in the background there you can see the tanks, and inside it's a membrane, and here you can see the core thing. You can see how the membrane how the membrane behavior is during filling and emptying of the tank. So that's, you can also see here that we actually have a membrane inside the tank, and salt or seawater is going in and out in the bottom of the tank. So we have a system. We can have it on shallow water, or we can have it on deep water, because it is ambient to sea, and that's the real beauty with this system. In addition, we are making the structure in glass fiber or composite material, so it's easier to install, and we can also be more flexible with regards to size and making the tanks. I will also say that the tank and the membrane is perhaps the core element, but of course how to monitor and how to control the system with regards to overpressure, with regards to leakage, and how much oil or chemical do you actually have in the tank. That's the kind of systems that's we are using a lot of time on. So to have control over that is very important. As some of us are aware of, oil is lighter than water, so we will actually have a lot of buoyancy in the big tanks. So then we have to have ballast on the tanks, and so they are not floating. So we need a big cluster frame and put it and connect it actually to the seabed. So then we need a cluster unit, and we need piping, valves, and all those kind of normal subsea equipment.
All right.
So just the last one is then that we can connect this to other NOV equipment, as well as risers and booster modules and the offloading system from APL. So it's really a beauty come together with other NOV equipment.
So if you just joined us, we're talking with Marius Bjorn, the business director for Subsea Products, and the title of our conversation today is a Subsea Storage Enabler for Tomorrow's Fields, a joint industry project. So if you have questions on subsea storage technology and would like to pose your question for Marius, feel free to put that in the comment section, whether you're watching us on LinkedIn, Facebook, or YouTube, and we will try to get to your question in today's show. So Marius, I'm going to pivot back over to you. I know that we talked about a few of the solutions that subsea storage units are able to provide. Could you talk about maybe some of the other applications or solutions and some of the goals and objectives there that we're trying to get done there?
Yeah. Well, as I said, we started to develop oil and condensate solutions for subsea use, and today the focus has moved to chemicals and ammonia. So I will go a bit deeper into those systems. And here you can see the chemical storage system that we have developed. The chemical storage unit consists of several tanks. Each tank has one chemical, and the goal will be to standardize the size of the tanks, so we can get it as to a low cost, and this can be also put in a cluster unit, or the cluster frame, as you saw there. We have also learned that for this chemical storage, it's important that they are quite big, because the business case for the operators are always the challenge, and with smaller tanks, it's that difficult. That business case is difficult to reach. So the goal is for us to build bigger tanks and reduce the number of service intervals for this system. We are actually thinking of having two sets of tanks. One tank that is 45 cubics for ppm chemicals, and a bigger tank that's perhaps 250 to 500 cubics for chemicals as methanol and MEG. So there are different ways of thinking for those. I will just also give you a summary of what we are thinking about the benefits with subsea chemical storage. I would say the first one is it can replace an umbilical. It can also give weight and space savings topside. It can give operators more flexibility with regards to commissioning, optimize required volumes in the storage tanks, connection to future templates, and possible. And it can also, if you have a different need, you can change the chemicals in the storage unit. And of course, in the end, it enables the full effect of the all-electric philosophy that is already established. So there are several benefits with this system. I will also say that a key enabler is long tiebacks. Long umbilicals are costly, and this system can have a good business case in those fields. Then the next one is ammonia storage, and here you can see a graph or a figure from ABS, and the DNV has a similar figure, and the gray area in the top is where you can see ammonia. The dark blue is oil-based fuel, and the gray is then ammonia-based fuel. And this is actually for ships and the shipping industry. They're using a lot of fuel. So how can they transform into a renewable modus? And the ammonia is perhaps the most one of the has the biggest potential to help the shipping in the future. So if you see here, there will be a lot of ammonia that's needed for the shipping in the future. That's one of the things that we can use ammonia for.
Mm-hmm.
Other things are actually ammonia can be used for power of offshore assets or offshore installations. You can use it as a battery with energy to the offshore asset. You can use it as a battery together with offshore wind. Where shall you store the energy when you have offshore wind farms? Perhaps ammonia is a possibility. And you have the established market that is there today. That's for the fertilizer industry. They are using a lot of ammonia. So to store ammonia in membranes subsea You need to be below 100-meter water depth, but except from that, we have many good sides or benefits with this solution.
Right. Well, I've got just a couple more questions for you, Marius. I know that we're getting some good questions coming in now, so I want to definitely get your insight and then make sure we have enough time for our viewers. So a quick one for you. So I know that you mentioned earlier you were talking about large scale qualification. Can you talk a little bit about why you're going down that path, maybe as opposed to an alternative approach?
Yeah, as I indicated, we have done testing on 3-4 cubic meter tanks, and we end up with a lot bigger tanks, and then our partners in the JIPs or joint industry projects, they ask us question: Can we trust the scale from 3 cubics to 10,000 cubics, for instance? And we ended up with that we actually need to do a large scale qualification test, and that's something we have worked together with Equinor and OGTC with, and we have a plan to do a large scale testing of our storage units together with them and other partners. We have learned a lot. I'm sure we will learn more in a large scale test program. So what we really need now is to establish that program together with several partners and then if there are anyone that see this technology as interesting for them, please reach out and we will be happy to include you in the joint industry project.
Good. Well, so maybe I know that you talked about, of course, the joint industry project, and certainly, yeah, if there are folks that are interested, we'll provide a way for them to contact you in just a moment. But as just a brief follow up, you talked about enabling the field developments for using this technology, which I certainly agree. Do you find that Subsea, the storage units, that these units will be used in kind of aspects such as like the energy transition and specifically, even talking about ammonia? Do you find that to be a position for those areas of the energy transition?
Yeah, ammonia as a hydrogen carrier has a lot of energy, and for sure we and several other both alliances and the companies, they have a strong belief in ammonia. So we have to make blue or green ammonia, not use the ammonia that we have today, that's brown, because that's not in accordance with the renewable philosophy. But for sure, I think I hope and I think that ammonia can be a significant part of our future for fuels to ships and to power other assets and facilities.
Okay, good. Well, I know we're getting close to our Q&A segment, but briefly, I know that you talked about the joint industry project and folks that were interested in doing that. Maybe the question could be posed: why should someone join the joint industry project? What would that benefit, and why would they want to do that?
Well, first of all, by joining JIP, you can include your requirements, and you can make sure that this novel storage technology will solve your pains. But most important is it to secure that the technology will actually be developed and it will be available as a product for our industry in the future. So we need to get together and develop tomorrow's technologies. We can see that producing ammonia from renewable resources has a lot of potential moving forward. If up to 30% of the shipping fleet can be powered by ammonia in 2050, it will be important to have a safe and economical solution for storage and distribution. So subsea storage is needed for the way forward for this technology. I will also say that subsea ammonia storage can be an important building block to provide clean power to many offshore platforms or also for houses and buildings. So we need to get together and develop this as a part of a bigger system. I know that there are other companies that are developing engines for ammonia and wind farms with the basis of ammonia as a battery. So there are technologies that are also developed in parallel with this initiative. So if you think this might be a good idea, we will be happy to have some meetings with you and discuss the possibilities, and we would be happy if someone wants to join to bring this technology forward.
And it looks like, as I understand it, the best way for them to reach out is, I think, an email address that we have, but it's subsea@nov.com. So anyone can reach out and reach out to you, Marius, or others on the team in order to get more information on the JIP, the Joint Industry Project, or more information on the subsea storage units. So that'll be great. Well, yep. We'll be sure to put that email on the screen in just a little bit. But while we work on that, we want to go ahead and bring in Shelby Dumaine to talk about the questions that we had in the comments section. I was glancing over a few times, Shelby, and it looks like, as always, we've got some really great convo going on.
Oh yeah, the comments were going off this episode, so I love to see that, and thank you everyone for sending us your comments and your questions. Definitely appreciated. So this first one, we got a comment from Philippe on LinkedIn, and he was just talking about how the solution could be useful in greenfield and brownfield. So I kind of wanted to turn that into maybe a more specific question and see, could you maybe talk about the chemical storage and injection systems, how they're useful in greenfield and brownfield, maybe if they differ at all, or how they work?
Chemical storage for greenfield first.
Mm-hmm.
If you have a long distance tieback or deep water with long pipelines, then it's quite clear that the business case can be good for that. For brownfield, it's more like if you want to add something to the existing infrastructure, and perhaps you don't have the chemicals that you need in the neighborhood. So then you can just add chemicals locally nearby the well and use it in that way. I will also say that many of the operators are today looking at unmanned platforms and to minimize the topside facilities. Then to store chemicals at the seabed can also be done just underneath the platform.
Mm-hmm. Excellent. Thank you for answering that more in depth. I know it wasn't technically a question in the comments, but I saw that and my curiosity was piqued, so I wanted to ask. So this next one is a direct question that we got from Facebook, from Hardik on Facebook. Here, I can show it there. And he was wondering, how many times can the membrane that we saw in that tank, how many times can that fold or unfold through the life of the storage unit? And I thought maybe I might add another one too there. I'm sorry, I can't help it. About what is the lifespan of these storage units?
Yeah, that's a good question. That's exactly what we are doing testing on. And how is the membrane behavior, and how many years can we use it? And we're doing cyclic testing. So we are qualifying membranes for 20 years lifetime, and developing materials that's in line with that. So that's very important, and it's a very good question. So what we see is that you will not fill and empty the membranes so often. So how many times is difficult to say, but for sure they shall last for 20 years. That's the big goal for us.
Mm-hmm. Absolutely. That's a good number. I like that. So this next one comes from Richard on LinkedIn, and he was wondering, are these tanks fiberglass or steel?
Yeah, good question again. They can be both. The good thing with steel is that it is heavy, and that's always good when it shall be at the seabed. But how the not so good thing with steel is that it is difficult to install when it gets huge. So we have an installation philosophy with composite tanks that we think are should be very attractive. We can also see that composite structures are very good when it comes to impact from troll and fish gear. So composites are actually, yeah, might be the cheapest solution as we see it today.
Yeah, absolutely. Yeah, we definitely love utilizing fiberglass when in different technologies. I always love learning more about it for sure. And this next question, it came from Didira on LinkedIn, but I maybe wanted to specify it a little bit more to get a more specific answer. So he asked, how do you handle pollution risk? But I maybe wanted to ask you how you handle pollution risk specifically for ammonia storage.
Mm-hmm. Yeah. The good thing, Ellie, if you store ammonia topside, it leaks out to the surroundings, it will be a gas, and that can be very complicated to have a safety system for that. Subsea, a leakage of ammonia is not good for the animals that's close to the ammonia, but it is not that bad as, for instance, oil. But what we have is that we have a dual barrier system. We have the membrane itself that protects as the first barrier, and then we have this composite structure around it, and we have leakage detectors. So if you have a leakage outside the membrane, you can monitor it, and then you can close some valves, and then you will all have the composite structure, or perhaps the steel structure, as a barrier number 2. So we have a dual barrier system, and that's what we think is important.
Mm-hmm. Absolutely. I appreciate you answering that. I know we get questions like that often, so I'm always curious to hear that side of it as well. And I think I'll round it out with one more question from the audience. Again, thank you everyone for submitting those questions and comments. This one comes from Leroy on LinkedIn, and he was wondering, do the chemical storage systems have any restrictions on the number of tanks?
What we have seen is that the business case is better for with bigger tanks. So we have looked at systems where you have 8 to 7, 8 different chemicals in that you need. So that's not a problem to have many chemicals. But for sure, the cost driver increases together with the smaller tanks.
All right. No, and that's really interesting, because that was one of the questions actually I had. I didn't want to jump in front of anyone that was asking online, but asking about especially scale and looking to see how you would kind of answer that particular angle. So that's really, really helpful. This has been really insightful, and certainly appreciate you providing feedback. So again, I've been speaking with Marius Bjorn, the business director for Subsea Products here at NOV, joining us live from Oslo. So wintry, snowy Oslo, as I understand it. So Marius, thank you for taking the time to share your insight and expertise with us on NOV Live today.
Thank you, Michael.
All right. Well, we are going to go ahead and round out today's show by getting you the answer to today's Rig Geek post of the week from Shelby. All right, Shelby. So I'm sure you got some really good answers. And to quote you, people were putting on the right hat. I'm sure.
They were, and I wanted to call myself out here first. As soon as I said, I think the answer is in miles, I had our team going, no, it's meters. And so that's my American showing.
Sure.
Answer.
I think the world will forgive you just this one time. It's okay.
But I did get the mile conversion, so I will go over that as well. But I wanted to show that question first. So there it is. We asked, what is the depth range for storing ammonia in a membrane subsea? So now we've seen that membrane. We've talked a lot about the ammonia storage. And so the answer in meters, we have the range is 100 meters to about 11,000 meters is that depth range. So definitely a big range there. And as promised, I did the conversions. We have for the miles, if anyone was wondering, it is 0.06 miles to 6.8 miles if you want to do that conversion, but it's better in meters.
Well, yeah, we'll just stick with meters around here. That's okay. That's okay. Good. Awesome. Well, great. Thanks, Shelby. Appreciate that for us. And thank you for joining us today on NOV Live. We are always excited to have you join us learning about new technologies, helping shape the energy world. If you have a technology that you would like us to take a deep dive on here on NOV Live, we are always open ears. So feel free to send us an email, and you can do that at at social media at NOV.com. Put in the subject line, the technology you'd like to see, and then write a few lines about what it is that interests you about that. And we'd love to have a dialogue with you there. So on behalf of all of us here at NOV, thanks for watching and for listening, and we'll talk to you again next time.